Okay, so we've been talking about systems of equations and finding solutions and things of that nature, right? Now we're going to flip over and start talking a little bit about linear inequalities. The purpose of which is to be able to get us to a system of linear inequalities. There are times that inequalities need to be used. Linear inequalities need to be used. So today we're going to try and talk about how to graph linear inequalities. Now, linear inequalities, linear equations are pretty much the same. We want to make sure that when we graph them, we're still going to graph a line. We want it to be in slope-intercept form. Linear, anytime you hear the word linear, that means you're going to have two variables in an equation. Very often it's going to be x and y. And so we want to put it in slope-intercept form, right? Y equals mx plus b, slope, y-intercept. Now the only difference is in an inequality, instead of this equal sign, we're going to replace it with one of these inequality signs. Now when we do that, that means that our solutions tend to change, right? X is equal to 1 and x is greater than 1 means that our solutions have changed. Here there's only one solution. Here there's a bunch. Remember that when we did this in one variable, which is what I just showed you here, we took a number line and we shaded it, we colored it to show all the solutions for the inequality, right? There was an open circle and closed circle and all that kind of stuff, right? The same kind of thing happens with linear, with two variables, when we start graphing lines, okay? So, combine those ideas, right? A linear inequality can be formed by replacing the equal sign with an inequality symbol. And the solution is any ordered pair that makes the inequality true. What you're going to find out is sometimes that ordered pair might be on the line and sometimes it might not. Okay? And we got to deal with how to show all the possible solutions. Okay? First things first. How do you figure out if an ordered pair is a solution? Well, it's the same as we did for linear equations. We're just going to substitute the point in for x and y and see if it makes the equation or inequality true. So for this first guy, I'm going to substitute 1, 2 in for the x and the y, 2 in for y, 1 for x, and is 2 greater than negative 2? Yes. So 1, 2 is going to be a solution. Try the next one. Is negative 3, negative 7 a solution? Okay, is negative 7 greater than negative 6? No. So this is not going to be a solution. And so that point would not need to be colored in or shown as a solution. Okay, so it's the same as before. We're still going to substitute in, but we understand that we're using an inequality now instead of an equal sign. So that does change the game a little bit. All right, now, how do we graph these linear inequalities? Well, we're going to graph these linear inequalities the same way that we graph linear equations. We want to get it in slope-intercept form. So get it into y equals mx plus b. And the same thing still applies. This is going to be your y-intercept. And your slope here is going to be 1 over 1. Okay, so we start at negative 3. Oh, sorry, negative 3. And the slope is 1 over 1. So we go up 1, right 1, up 1, right 1, up 1, right 1. We can go down 1, left 1, down 1, left 1. And that's going to be our line. So we draw a nice straight line right through those points. Okay? Now, think back. I talked a lot about this. I keep trying to talk about. Think back. Why are we graphing that line? For linear equations, why did we graph that line? And it's because that line represents all of the solutions to that linear equation. So if I pick any point on that line, it should work in a linear equation. But this is not an equation. It's an inequality. So my question for you is, pick a point on that line. and see if that line truly is a solution to this inequality up here, right? Any point on that line at all, right? We can check that point right there, which is 3, 0. 3, 0, since it's on the line, should be a solution to this inequality. So check it. Plug in 3 for x, 0 for y. So this is going to be 0 is greater than 3 minus 3. And so 0 is greater than 0. Is 0 greater than 0? Well, no, it's not. It's equal to it. So for an equation, 3, 0 would be a solution. But for this inequality, it's not. So we can't color that point in. As a matter of fact, if you check any other point on this graph, on this line, it's not going to be a solution for this inequality. So I don't want anyone thinking that a point on that line is a solution. So what we do is, instead of coloring those points in, which is what a solid line does, we dot this line to show everybody that those points are not solutions. Okay? But we still need the line because it creates a border between solutions and not solutions. Okay? So, here's that graph again. And so the difference between a solid line and a dotted line is simply that. If the points on the line are not a solution, we dot the line. If it is, we make it solid. Now, a rule of thumb here is that if your inequality is not equal to, if it's just less than or greater than, then we draw a dotted line. It means that the points on the line are not solutions. It's kind of like our open circles from when we were doing this for one variable on the number line. We did open circles when it wasn't equal to, because that number itself was not a solution. But if it's less than or equal to or greater than or equal to, and the points on the line are solutions, then we draw a solid line. And a solid line means the points on the line are included as solutions. It's kind of like our closed circle when we did this in one variable. Okay? Now, there are actual solutions to this. Right now we haven't shown any solutions because the points on the line are not solutions, but there are solutions. For example, let's check this point, 0, 0. It's not on the line, which is good because points on the line are not solutions. We just established that. Let's go check 0, 0 and see if it is a solution. Plug in 0 for y, 0 for x, and we get 0 is greater than negative 3. Is 0 greater than negative 3? Okay? Yeah, it is. 0 is greater than negative 3. So, we know that 0, 0 is a solution. As a matter of fact, if you were to go through and check any other point on this side of the line, any of these points would work. Any of these points would be solutions. If you were to check a point on the other side of the line, and I'll do it for you really quickly, so maybe 4, negative 2. Let's check that point, 4, negative 2. Let's go check that point. I'm going to plug in, let's see, 4, negative 2. Plug in negative 2 for y, 4 for x. Negative 2 is greater than 1. Well, no, it's not. So this point is not a solution. What does that mean? It means that one side of the line will be solutions, the other side will not. And since we've established that 0, 0 is a solution, then that means I'm going to color in, remember that we always color in solutions, I'm going to color in that side of the line. That's why we still need the line. The line is a border between solutions and non-solutions. Okay? So we're going to color that side. Now, a rule of thumb for coloring in. And I'm going to show you the rule, but I don't really use the rule very often. I like this checking points personally. Okay? But the rule of thumb is this. If your inequality, if when you're in y-intercept, if you're in slope-intercept form, okay? And your inequality is greater than or equal to, then we're going to shade above the line. And if it's less than or equal to, we're going to shade below the line. Okay? That's not a bad rule of thumb. If you go to your y-intercept, and if it's greater than or equal to, shade all the points above that y-intercept. Okay? And if it's less than or equal to, shade below. It's not a bad rule of thumb. It's just as that line tilts and becomes more vertical, it can be kind of tough to tell. I like the check a solution method. Okay? And there's a question over here, is 1, 2 a solution? Is -3, -7 a solution? We can actually use the graph to figure that out. We did that already above, but we could go check that out. 1, 2 is what? This point right here, which is in the shaded area, so it is going to be a solution. -3, -7 is right here, which is not in the shaded area, so it's not going to be a solution. Okay? So, let's put this all together and start graphing these guys. Y is greater than x minus 2, right? We're already in slope-intercept form, so we're good. We're good to go graph. So we go down to, on the y-axis, to plot our y-intercept. Our slope is 1, right? This is our y-intercept. Our slope is 1 over 1. So from here we go up 1, right 1, up 1, right 1, up 1, right 1, or down 1, left 1. And this is the line that we're going to draw. Okay. Is it a dotted or solid line? Again, the rule of thumb is it's not equal to, so it needs to be dotted. Okay? If it were equal to, it would be solid. And again, it's because the points on that line are not going to be solutions. Feel free to check any point on that line to see if that's true. Okay? Now, which way are we going to shade? You can use the rule of thumb. Okay? The rule of thumb here that I showed you before says that from the y-intercept, since it's greater than, we're going to shade above this y-intercept point. And that might make enough sense here for this line. I am going to check 0, 0. I am always going to check the origin to see if that origin is a solution. If it is a solution, I know I color that side of the line. If it's not, I color the other side of the line. Okay? I like doing this because, I don't know, as I said, there are some lines where it can be kind of tough to tell which way to go up, down, which way, that kind of stuff. But it also keeps reminding me that we're trying to show solutions. So if I plug in 0 for y and 0 for x, we get 0 is greater than -2, which is true. And so all of these points up here are going to be solutions. Okay, and that's what the rule of thumb said also. Okay? I'm going to keep checking. All right, try the next one. Stop the video, graph that line, come up with solid or dotted, and then shade which area you think needs to be shaded, and then start the video back up and check your work. Okay, hopefully you came up with this, right? Y-intercept is -3, slope is -4 over 5. And so your line should look like this. It's going to be dotted because it's not equal to. And I checked 0, 0, right? Now, the reason why I checked 0, 0 is because it makes the math really, really easy. You plug in 0 for x, it doesn't matter what the slope is. Anything times 0 is 0. So you get 0 is less than -3, which is not true. So since 0, 0 is not a solution, I need to shade the other side of the line. Okay? If you want to use the rule shown before, that would work here too. Okay? Try this guy, or we'll do this one together, because it's not in slope-intercept form, and we need it to be. This guy needs to be in slope-intercept form. So, just like we did with equations, we're going to get it there, right? Get y by itself. Add 2x. Always move the x term first. Bring down the minus sign as a negative. Then we're going to divide through by negative 3. Now remember that when you divide through by negative 3, the inequality sign switches. Okay? That's going to make a huge difference. So go down to negative 2. That's my y-intercept. And then the slope is down 2, right 3. Down 2, right 3. Or we can go up 2, left 3. Up 2, left 3. And then draw your line. Solid or dotted? Well, it's equal to, so we leave it solid. And then I'm going to check 0, 0. 0, 0. I'll get 0 is greater than or equal to, this is all 0. 0 is greater than or equal to negative 2. That's true. So I'm going to shade above this line. Here. You notice I'm shading outside the grid because numbers do extend past that grid, and those are all going to be solutions also. So I want to make sure that we understand that. Okay? All right. You try. Try this guy, stop the video, see what you come up with. Okay, did you come up with this? Okay, you get y by itself. Remember, you have to flip the inequality sign around because you divided by negative 2. You should get 3/2 xy is less than 3/2 x minus 4. Negative 4 is your y-intercept, 3/2 is your slope. And then when I checked 0, 0, it did not work. 0 is not less than negative 4, so I'm going to shade the other side away from 0, 0. And so we shade that. Okay? All right. Another one here, just like it. I'm going to walk through this real quick. Add 3x. Divide through by 4. You don't have to worry about flipping the inequality sign here because you're not dividing by a negative. Okay, so we go to 4. Slope is 3/4. So up 3, right 4. Up 3, right 4. Or down 3, left 4. Down 3, left 4. Not a great line, but it's there. Now, it's solid because it's equal to. I'm going to plug in 0, 0. 0 is greater than 4. Is 0 greater than 4? No. So we're going to shade the other side. Okay? It's that simple. Okay? All right. Graph this next guy. X is greater than negative 1. Vux and Hoy. If you guys remember Vux and Hoy, then this will be a lot easier, right? Same thing, same rule applies. Vux. V means vertical. U means undefined slope. And the equation should be x equals, or x is greater than, or greater than, less than, whatever. X should be the only variable in the equation, or inequality. Okay? For inequalities, another way to look at this is the solutions are going to be all x's that are greater than negative 1. It means we need a boundary that separates negative 1, x equals negative 1 on the x-axis from everything else. Now it's not equal to, so I need a dotted line. It's going to be a vertical line through negative 1 because of v, Vux. And x is greater than negative 1. So simply enough, You're going to shade over here. Now you could do the 0, comma 0 if you'd like, only you're only going to plug in 0 for x. 0 is greater than negative 1, and that definitely works. Okay? Same thing here. Y is greater than or equal to 2. Hoi. Horizontal, 0 slope. Y is the only variable you would see. Through 2, so it's equal to, so we're going to draw a solid line through 2 on the y-axis. Y is greater than or equal to 2. So we want all y's that are greater than or equal to 2. Okay? Piece of cake. Try this guy. Actually, next, this example here. Give them a shot. See what you come up with. Stop the video, start it back up, and see how you did. Should look like that. Hopefully it did. If not, make sure you come see me. Okay? Now, we can work a little bit backwards here as well, right? If we give you the graph, you should be able to come up with the inequality, right? There's the answer choices here that you can try. So here's the thing. Come up with the y-intercept first. It's right there. So y-intercept is 1. Doesn't help us weed any of the answer choices out, but at least we're on the right path. Slope. I need to walk to the next street corner, which is right there. Right? I got to go up to right 1, which means the slope is up to right 1. So now I can eliminate this guy. Okay? Next, it's a solid line, so I know it's got to be equal to, so that guy's gone. And then 0, comma 0 apparently is a solution. It's colored in. It's on the side of the line that's colored in. So go check 0, comma 0 and see which one is a solution. Right? You get 0 is less than or equal to 1. Is that true? Yeah? I think the answer is A. I'm going to check C just in case. Is 0 greater than 1? No. So that's not an answer either. So it's got to be A. Okay? All right. And then last but not least, a little bit of a story problem here. For a party, you can spend no more than $12 on desserts. Brownies cost $2 a dozen. Cupcakes cost $4 a dozen. What are 3 possible combinations of brownies and cupcakes you can buy? Now, I'm going to do an equation first, right? What 2 things do we not know? Right? I need to know. X can be the number of dozens of cupcakes, and Y can be the number of dozens of brownies. It doesn't really matter. One doesn't depend on the other. So X and Y doesn't really matter a whole lot. Okay? Now, $12. That's how much we got. Right? Brownies are $2 a dozen. So however many dozens of brownies you buy, you've got to multiply that by 2 to find the cost. So 2y. And then add to that $4 for the cupcakes. So 4x. And normally I put an equal sign here, but it says you can spend no more than $12. Right? It means your cost, or 12, has to be greater than or equal to, or in other words, your cost has to be less than or equal to 12. And so there's your inequality. We need to go graph this guy. Subtract 4x. We get negative 4x plus 12. Divide through by 2. Y is less than or equal to negative 2x plus 6. Okay, now, we go graph. 6 on the y-axis. 1, 2, 3, 4, 5, 6. Then we go down 2, right 1, down 2, right 1, down 2, right 1. Right? Now, it's equal to, so I'm going to draw a solid line. And I want to check 0, 0 to see if it's a solution. So 0 is less than or equal to 0 plus 6. Is 0 less than or equal to 6? The answer is yes. So that means that all of these guys are solutions. Now, outside of this lines would normally be a solution as well, but the problem is we can't have negative, and we need to label these. This is dozens of what? Cupcakes. This is pretty sloppy. And then y is dozens of brownies. And we can't have negative dozens. Okay? So going to the negative side of the x and y axis doesn't make any sense. Now we need 3 possible combinations. And remember that the 3 possible combinations need to be solutions. We just established that 0, 0 is a solution. But any other point inside this shaded area is a solution. So your 3 possible solutions, 0, 0, so maybe we can not buy any. 1, 1 is a solution, so we can buy a dozen brownies and a dozen cupcakes. 1, 2 is a solution, so we can buy a dozen cupcakes and 2 dozen brownies. There's a bunch you can choose from in there. And that's how we're going to choose them. Okay? And that's it. Hopefully that makes enough sense. Homework's out in Canvas. Make sure you get that done.